Started. Can everybody hear me in the back? Does the mic work? Cool. I think I need to be like at this distance to the mic to be on the video as well. So my name is Mike Schilli. I work at Yahoo, and I'm working in a group that's supporting operations by creating tools in order to roll out new releases of software really fast and in a way that's highly scalable, because you can imagine that Yahoo runs a lot of servers, and it's not unusual that we deploy to 1,000 or sometimes even tens of thousands of hosts at a time for a new release if you have a property that draws lots of traffic. If you roll stuff out, then you want to make sure that you roll out as fast as possible, and because, you know, operations doesn't want to sit around and wait for it, and you want your stuff to show up quickly on the live site. On the other hand, you need to be careful wedging the site if you do that. So you want to have some control over how fast you roll out and stop if something goes horribly wrong. The system that we use is written in Perl, and it's been in use for several years, and we've been working on open sourcing that tool. It's called Pogo. So I got to put in a huge disclaimer, because Pogo is not production ready yet, at least the version that we have in the open source world, which is on GitHub. But we're working feverishly on getting it done, and my estimate will be that a month from now we're going to roll out the alpha version that you can work with. And what we have right now is more like a demo version, which is very limited. But as I said, it's being finished up. There's several people working on it, and we hope that we have something for you guys soon. Now is a good time, by the way, if you have anything that you want from the system, and if you look at the code and you want to put in something, let us know. We will happily accepting patches for it. So let me show you how Pogo integrates in CI environment. You can use it manually too. I mean, if you have a couple of servers and run Pogo, Pogo will deploy stuff on these servers. But typically it's used in a CI process. You have a code repo, like a Git repo or SVN. You check out code on a regular basis using a tool, a CI tool like Hudson or something else. Run the test suite. Maybe create packages like Debian packages or something like that, and then you hand it over to a tool like Pogo, which is very limited in its use, in that all it does is it connects to target hosts and then runs commands on these target hosts. And whatever the command is determined by you. So you choose whether you want to run a apt-get upgrade or updater like that, or use Puppet in order to configure your host in a certain way. So all that Pogo does is execute stuff on a huge number of targets. So in Pogo's case, this is just usually a single command. You specify what host you want to run it on, what the command is, and of course your command could be anything. It could be a shell script that does something specific for every host, or I mean the possibilities are endless. At Yahoo, what we do is we have a central database that determines how every host is supposed to look like. So a host might be a web front end, or a database server, or a cache. And whenever you run a specific command on that particular host, the host goes back to the central database, figures out what am I supposed to look like. So the central database would say something like, you need Apache 2.4 and MySQL 5.3, and then this command that runs on the host will then fetch it from either a central repo or a repo on one of many edge servers in order to bring that host into a desired state, which the desired state being defined in the central repo. This might be different in your case. You might rely on Ubuntu or like a repository with the Debian packages, and it's totally up to you. So if you run a command on many hosts, ideally what you want to happen is this, right? So you start the deployment process all in parallel, and magically a couple of seconds later everything is done. But unfortunately, that's not how it usually works. If you have different applications, you might have certain requirements. For example, you might have the requirement that you cannot take out more than 25% of your boxes, because then it would melt down with the live traffic coming in. So your SLA says you always have to have 75% availability on, let's say, the web front web servers. Also, you might have a requirement that says the caching host runs software that requires the web front ends to be updated first. So you might have a dependency there, so that you need to run your updates in a specific order. So you, for example, you might have to start the caching host, and also you have an SLA here that says you can only take out one caching host at a time, and you need to wait until all of your caching hosts are ready in order to proceed with the front ends. And Pogo lets you do that because it lets you define sequences, which is something like do the caching servers first and the web front ends afterwards. It lets you parallelize. So you can say, I want 100 hosts in parallel, and if let's say if let's start with a smaller number. Let's say like 3 hosts in parallel, right? And then if you have a number of errors, and let's say you started with 3, and then all of these 3 hosts fail, what are you going to do? Pogo will stop at this point and say, wait a minute, you just violated this constraint. You said you cannot take out more than 3 hosts, but I just took out 3 hosts because the update command that you gave me failed on these boxes. So that's very important if you roll out stuff, that you can ask Pogo to stop if something goes horribly wrong. And then without you even manually checking every host, Pogo will make sure that it will never violate these constraints that you've defined up front. Pogo will figure out whether something went wrong or not by running pre and post hooks on your command. So you give Pogo a command in order to update something on a host, and before it does that, it runs a pre-hook, which is some kind of shell script usually, or a Perl script on that host that does something useful. And if either the pre-hook, which runs before your command, or the post-hook, which runs after your command, fails, Pogo will mark that host as failed and will not, and will count that into that threshold that determines whether it can still proceed or not. And as I said, Pogo is command agnostic. You can put in pretty much anything. And also, regarding these hooks, you can plug in any shell script, any Perl script, anything that runs on that host. So to come back to the previous example with the caching host, that you can only take out 1 at a time, and the web front-end servers that you can take out 5 at a time in order to do the update. What happens if you configure Pogo to do that is this. So it will start off with 1 caching host. We'll make sure that one succeeds. It will continue with a second and a third one. And when it figures out that all the caching hosts are done, it will move on to the next link in the dependency chain and start with 5 web front-end servers, because we said we can take out 25% of all the web front ends at a time. And it will continue to do that until everything is done and everybody's happy. So this particular configuration would look something like this. We have a configuration file. We tag certain hosts with certain values. So in a very limited example, I've used host 1 and host 2 as front end, and host 3 and host 4 as a backend. And my sequence command that is listed right under it determines that first we need to run all the backend hosts and followed by the front end hosts. Also, the constraint clause that's listed at the end of this configuration file says that I can only take out 5 front end boxes at a time in order to run the upgrade. And for the back end, which was this cache in the previous example, I'm defining that I'm running 1 update at a time. If I then run my Pogo command, so these configurations are more or less global for your, let's say for your company, or for, you can split it up in different namespaces, and a Pogo command specifies a number of hosts within those configurations. So for example, if I wanted to run my update command, which I just replaced by a simple date here in order to run some tests, then on all of my front end and my back end servers, then I define my range here, and Pogo will go back to the configuration, figure out, front end is host 1 and host 2, and back end is host 3 and host 4, and then we'll determine a schedule in order to execute these commands to enable you to follow along with what's going on when Pogo runs. It spits out a URL to a UI, a web UI, and you can follow along what's happening there. This is quite helpful in figuring out if something goes horribly wrong, and it's also good if you want to go back and check out a job that you ran a couple of weeks ago, figure out if everything went okay there, or if there was something wrong, to look into that. Also, you can figure out by the green bars. They're not really visible as green bars here, I think. They're listed in sequence here, which means that Pogo, because of some constraints that you've defined, updated 1 host at a time. If these timeline bars were all stacked on top of each other, you'd see what Pogo ran in parallel. So since Pogo can be used if you install Pogo system by several users, you can check out what other people are doing. So you might want to configure that to your use case, of course, because sometimes you don't want to share with other people. But at Yahoo, we identify users on the web front end, and then you can figure out pretty much what everybody else is doing. So this also means that if there's something wrong with the Pogo system, you can figure out maybe there's multiple jobs that are currently failing, and it's probably time to alert the Pogo team that something wrong with the software. And if it's just your job that's hanging, it's probably something that you did. Every single host you can look at in the Pogo UI to figure out what happened on that particular host. So it will list the command, and it will list the client command that you've used in order to trigger that job on the Pogo system. By the way, so I said that Pogo is not yet ready in the open source version, but you can look at this UI, which has been designed by the Yahoo UI folks. I personally couldn't do something like that. So it's really nifty JavaScript stuff. And if you check out the GitHub source and run the commands up there, you'll get both an API server, which is used by Pogo in order to query your data and to submit jobs to the system. And if you also fire up Pogo-UI, which starts a simple web server that spits out an index HTML file that contains all this JavaScript magic in order to drive that dynamic UI, then if you point your browser to localhost port 5000, you'll see the data that's in there, which is currently only canned data, so this is all smoke and mirrors right now, but hopefully we're going to get the real Pogo data in there. In the previous client command, I showed you how to run your front-end and back-end servers, but you can also specify simple hosts in your range. So in this case, I don't want to deploy everything that's covered in my configuration, but only host 1 and 2. And then Pogo will figure out in the configuration that, okay, host 1 and 2, for example, are only in the front-end group, and front-end has this constraint of max parallel 5. So it will just update host 1 and host 2 in parallel, and is done quickly with that. Again, Pogo is currently available on GitHub, and the directory is Y toolshed. So all the Yahoo stuff starts with a Y for some reason. And toolshed and /Pogo. And on the master branch, you can follow along what's happening. As I said, there's currently 3 people working on it, and we're really pressing on getting it done. I would estimate that probably in a month or so you'll have something to play with. Also, we at Yahoo internally will be using this open source version and add some plugins to it. So this might be applicable for you as well if you, for example, if you have a different source of truth for what your servers look like. You might not want to specify everything in this YAML configuration file that we use, but you might have a database that says this host belongs to this group of hosts, for example. And we definitely need that within Yahoo. So we're using the open source version plus plugins in order to adapt to our internal infrastructure. So that was the project as it is on GitHub right now. It is also hooked up to a CI test service called travisci.org, which is a really nice tool if you have a project on GitHub, a Perl project, and it takes you literally 3 minutes, I'd say, in order to get CI working, which means basically it checks out your GitHub repository and runs a test suite as soon as you check something. And has anybody used here travisci.org? It's virtually unknown. It's fascinating. So the way it works is that Travis CI will ask you to log in to GitHub and look at your repository, and it will give you a list of buttons for every single repository that you own. And you click the on button, which is all it, or virtually all it takes to get your GitHub project CI tested on an ongoing basis. So travisci.org will then install a hook on GitHub, which will be triggered every time you check something in. And as soon as you do that, it's fascinating to watch. So you have a travisci.org window, and you have a command line, and you check something into GitHub, and it will immediately trigger the test suite and run it and send you an email if something is wrong. So very cool stuff. If we have time at the end, then I can go into that a little bit more. So that was a lot of stuff. I wonder if you have any questions so far before we go into the gory details. I mean, it's a lot more complicated than internally than it looks from the outside. So I wanted to give you some insight. But before we go to that question.
Can you go back to your previous example where you specified just host name 1 and 2?
Yes. Going back to this example.
In the configuration, you've got sequence backend and then frontend.
Yes.
So to me, this begs the question. So this means if you only specify host 1 and 2, that means you're skipping over the backend. You're not blocked because there are no backends to hosts.
Yeah. So the question is, if you only specify host 1 and 2, you only have hosts in the front-end group, but your sequence says that you have to start with the back-end group and then proceed with the front-end group. So the rule is if there is no hosts in the back-end group in your specific job, then you can just ignore that. If I had host 3 listed in the list of hosts that I want to deploy to. Then Pogo would have to do host 3 first, because backend comes before front end, and then proceed with the front end host. Okay, so gory details, because if you look at Pogo from the outside, all you see is that you have a command line client, you have a web UI service that you submit jobs to through the client and get results back through the UI. And in the end, some magic happens, and Pogo runs SSH commands on targets. So for this to be scalable, you need some replication in there. So we have components called dispatchers, which figure out in which order to deploy stuff. So those dispatchers will read your configuration. They will go into the host list that you've provided for a command and figure out things like, yeah, this front-end host needs to be run before that back-end host. And once the schedule is figured out, the dispatcher will forward a request for a single task to a worker. And the worker task basically says, connect to this target machine, run this command, and give me the output. And then the dispatcher will collate that information, figure out if that violates any constraints, and if not, it will proceed with the next host in the sequence. So if you have multiple servers that need to synchronize, you need some way of them communicating so that they are not processing tasks twice. Or if one dispatcher goes down, you want to make sure that another dispatcher takes over for it, because what you want is a really reliable system. And it's, well, it is important that you roll out reliably, but what's even more important is that you roll back really, really fast and reliable. So nothing is worse than, you roll something out and you figure out you made a really bad mistake and you need to roll back really quickly and your deployment tool is unavailable. So that's usually cause for trouble. And I'm not saying that that happened, but it's a possibility. So in order to communicate between those dispatchers, we use a tool called Zookeeper, which is a Java-based system that allows you to keep a limited amount of data in sync between different hosts. And you get stuff for free, like you can lock stuff in there, and it basically figures out if one of the components, like one of the dispatchers, goes down, it will maintain the data consistency of this shared data for you. So it's fairly magical. And what it uses in order to figure out who's right and who's wrong is something like leader election. So you need typically like 3 different components so that you always have a majority if one of the systems misbehaves. So if, let's say, one of the dispatchers is wrong about the data, it can be overruled by the 2 others. Anyway, so the Zookeeper stuff is just a tool basically to like synchronize the data between the dispatchers, because you have certain tasks and jobs that you need to execute, and all the dispatchers need to have the same view of the data and pick a job if it comes in and distribute it to the workers, and other dispatchers need to take over if a previous dispatcher just falls off the grid. The other box on the right-hand side, labeled DB, that is our internal database that determines which group a host falls into. So if you don't want to specify a tag for every host in your configuration file, because you already have a database that does that, and of course you want only a single source of truth for everything, we use this database in order to do that, and it's basically a plugin that adds to the data that's in the configuration file already. if you want to use Pogo, like when the client submits a job, at least in our case, you need to run through a web authentication system, because you want to keep track on who's running commands on your hosts. It's always a good thing to know, so that if there's any misunderstanding, you can follow up later. And you also need to authenticate with a target. So that introduces the problem that you probably know the password or the private key to the host that you want to access in the end, but Pogo needs to somehow push that through that chain. So the client talks to the API, and the API talks to the dispatcher, and the dispatcher talks to the worker. And then somehow you need to end up in a situation where the worker knows the password, for example, to respond to a prompt on the target, the SSH prompt for your password, to run the command. And the way this is implemented in Pogo, at least the version that we have in-house, and soon to be, it's soon to be going to be part of the open source part, is that we encrypt that password that you provide when you run the command with the Pogo client with the worker keys, with the worker public key. So the only entity that knows the password is the worker, and the password is never stored anywhere persistently, obviously, because it's very sensitive information. Also, you can set it up so that the worker is trusted by the target. That's also a possibility, but in our case, we run the system company-wide, so we need real authentication between the worker and the target node. I talked about hooks previously, so that's a mechanism that Pogo figures out whether a command that you've submitted succeeded or not. And I also told you that those are just the regular scripts that are written either in Perl or just can be any executable. So these are used to check the health of the host after you've installed something, or even before that, so Pogo knows that it can proceed. And these hooks are just installed on the target, typically some directory in rc.d style, so that the hook just runs everything that's within that directory, so it can easily add and remove scripts in order to get that done. So the pre-hook runs before the command, and the post-hook runs afterwards. And examples of that are, for a pre-hook, for example, you might want to take a host out of rotation when you're doing the update, because you don't want any users ending up on that host while it runs, because that might lead to unexpected behavior. You might drain database connection, you might flush caches and exit user sessions, stuff like that. So you just make sure that the host is ready to be updated. Post-hook examples, on the other hand, they could be used in order to, if you, for example, update the web server, you want to run a quick test whether it actually serves up the web page that you're expecting. This is just a way to ensure that what you've run on the host actually succeeded, or you can ping required services. And also, if you're sure you're done, you can put the host back into rotation so that it serves live content again. And the important thing to keep in mind is that if failures occur, this counts against the constraints. So if you said, I want to run 5 hosts in parallel, and all of a sudden you have a host that fails, and I guarantee you if you deploy to 10,000 hosts, there's always one that fails. That means that Pogo will proceed with only 4 at a time afterwards. So you will never have more than the allowed number of hosts that are currently inaccessible because something didn't go right with the deployment. So that was pretty much everything I had to say about the use case, or how you use Pogo. And again, it is currently pre-alpha, so be patient. But if you want to start hacking on it, please let us know. And I can talk about the implementation of how it's done. It's all asynchronous, but I just wanted to take the opportunity to figure out if there's any more questions on what Pogo does and how it's doing it. And all right. Yep, question?
For the hooks, the return values are just exits, error values, or strings, or do you check standard out and errors?
How do you determine whether a command failed was the question, I think, yeah. And then all we do is check the return value. So you run an SSH command with a command for the box, and that returns either 0 or it returns some error code. And if it's anything other than 0, then it's marked as failed. And the same applies to the hooks. So if a hook returns a non-zero value, then it is marked as a failure. How many of you do know how to raise up in any event? So this seems to be, here we go, one person, two, not too many though. It's a really cool tool in order to implement, components that talk to each other over TCP, and it's this whole concept of having an event loop and reacting to events instead of having this linear style of programming where you execute one command after another. It looks kind of weird at first, because if you, for example, look on how this HTTP post works, is that you need to provide a subroutine that Perl jumps into after the command is done. So if you run that command like it is, or the script as it is listed right here, then it will basically immediately go to that last statement and jump over the HTTP post, because it won't wait until that HTTP post is over, but you need to block it a little bit so that whenever the post comes back from the network, which takes an order of magnitude longer, obviously, than processing a Perl statement, in order to get the result back, and what any event does, so there's a couple of different asynchronous frameworks. For example, PoE is one that I've used for years, but any event seems to be the latest development in that area. What any event does is that it doesn't have a not an explicit event loop. So in PoE you would say, okay, here are my components, start all these components up, and then you run what's called in PoE the kernel. And that kernel just waits for stuff to happen. It just sits around, and then one of the components might send something to the kernel, and then the component listens to that event and sends something back. And this is how they communicate. So what's important is that if you run any asynchronous code, you can never dilly-dally around and do stuff like read bytes from the network or from a file, because that's way too slow. You can never slow down below the speed of what can be processed immediately. Whenever you have something like that, you need to branch out and say, okay, I'm going to call you back once that is available. This is how it works. And this leads to this weird style of jumping into callbacks instead of getting something returned from a function. And any event has this implicit event loop, in that you just wait for stuff to arrive in a conditional variable. So the second line in the listing defines a conditional variable, and conditional variables are used to listen for stuff and send stuff. So the recv in the last line of the script will wait for a signal to arrive at this variable, and the signal won't arrive until that callback gets called from the post command. So this will take maybe a second to go to this URL, and it will run the dumper, and then it will send a signal to the variable, and this means that the recv at the end will stop blocking, and the program will return. So this is actually a fully functional HTTP post that is waiting until the data trickles in from the web server. Is that clear? Okay, and as I said, it's an implicit event loop because you never start a command that says listen to events. It's just magically because you wait for something. And this, as I said, leads to this weird style that you keep nesting stuff, right? And then because you don't have this linear flow anymore, you jump from callback to callback to callback, and you need some way to control this because it gets unwieldy if you keep doing it. Not only will it exceed your terminal width, but it's also very hard to read. So there is a module on CPAN that I found very useful in order to program any event components that are increasingly complex, and to like build a system that contains many of them, and that is called object event. And that is just a class that you let your classes inherit from, and all of a sudden you get two methods. One is called event, and that is a way to have your class send out an event to anybody who's listening to it. And somebody who's using that class registers to this event and gets notified once this is happening. So this helps tackle complexity. So if you had another iteration of this silly example that you have a get followed by a get, and instead of nesting this, I'm nesting it only once in this case because I have a get-getter package that uses this getter, and then the newly created getter registers the event HTTP get done from the getter and forwards that to the component that's listening to this class in turn. So you can build these event chains that we call that stack class after class after class, and then all the events that are sent by even a remote component trickle up all the way to your main program. And in case of a test suite, you have the ability to track what's going on even deeply inside the system. So this is how the main program uses this. And as I said, it's very convenient to test stuff. Let me just show you how test suites work in this case. So, for example, the Pogo scheduler, that's the guy who takes the configuration and figures out which hosts to run in which order and how many of them at the same time. So if I wanted to test, let's say, a new configuration in my test suite, and the Pogo test suite on GitHub has, I think, something like 64 different test files. So you can easily subscribe to an event, let's say, that's coming from the worker. And although the component that I'm running here is a scheduler, the way this event chain is set up is that the worker sends, if it's all running on the same host, by the way, that's what the test suite does, and it's not this distributed model. You can actually catch these events in the test suite and run your test command. So if you look inside the anonymous subroutine, this actually runs a test that with the is command and verifies that the task that was just processed is indeed task 1, the task that I submitted previously. So if you look at how Pogo is implemented, it is a number of different components that are designed to run on different servers. But for testing, you can run everything in the same process, which is really useful because I hate running test suites and you have to start up 3 different processes, three different servers that talk to each other. It's much easier to run everything in one process. So the components don't care. You can run 3 different web servers and a TCP server and a client all in the same process with any event. And that's exactly what the test suite does. And yeah, they open up the ports and do the communication. It's no problem. So in order to have something to play with it, at least for right now, on GitHub. I bundle all these components into a Perl script called Pogo 1, which is like everything in one. And with a little bit of luck, you can actually use it like that. So you can figure out how Pogo would behave with a configuration that you've specified. So this is very shaky right now, and because it's still work in progress, but it's a great way to test that it's actually working, and splitting it up later on and putting it on different hosts, it's just a no-brainer because these components already exist. All right, there was a lot of code and maybe some programming styles that not everybody has used before, so I'll take another round of questions if you have some. Randall?
Have you looked at salt?
Have I looked at salt? I'm not familiar.
Yeah, it's accomplishing something in a similar area. So it's basically for parallel execution of commands with management in terms of, it doesn't have the sequencing things that you've got, but it quickly parallelizes execution across multiple hosts. It uses 0MQ as the underlying communication layer, so it's a really nice combination. We're using some of it at Media Temple.
Okay, I'm aware of a product called Rundeck, which is kind of similar. So there seem to be several approaches. The advantage of having something in Perl is that we can integrate it with the tools that we already have. So, and especially it's often not that easy to extend an external product to your internal databases. So if everything is in one hand, it's always an advantage. And also, yeah, I'm not sure about the scalability of other products. We definitely know that it works for tens of thousands because we've tried it. It's 2:12. I think we got 8 more minutes. I can take more questions, or I can go into some bonus slides if you're interested. The kind of lessons that we learn along the way. So this Travis CI service that I mentioned, it's a free service, and what they do is they run tests on GitHub and then display the results and send you an email if something's broken. So you have your typical Perl make file PL and make test command, and this should result in something like this if the test suite succeeds. Can you read that? Wow.
Black on black.
Works here.
We're going to get up and huddle behind it. Weird.
Does that work? Is it better?
A little better. I can see okay.
All right. That's all there is to it. It's all okay. We're all good. So that is better. Let's check if that does it. Yeah. This is how it's displayed on Travis CI. So it will display the commits that it ran the checks on and what the result was. If you're familiar with Hudson or Jenkins, that's similar. So you get a green balloon or whatever that is if something is okay. And all you need to do in your GitHub project is define a Travis YML file. And they kind of infer how to run the test suite by the language that they're using. So you say language Perl, and all of a sudden it knows, oh, Perl has makefile.pl that defines the dependencies, and it has a make test target that's available after I run Perl makefile.pl. And you can also specify the Perl versions that they run it with. So currently they're supporting 5.10, 5.12, and 5.14. And once you've checked that one in, you go to travisci.org. They ask you to log into your GitHub account, and will retrieve all the, it's like OAuth authentication, so they don't really know your password, but they have access to your data, and they will give you little buttons here that you just need to switch on and off, And if you switch it on, then testing is on for your GitHub project. So I would have thought it would never work, but it started working right away. So I was pretty amazed by that. So the pitfall with this is, of course, if you go back to GitHub, GitHub asks you, do you really want to authorize Travis? And it's kind of scary because they basically get the rights to do anything to your repo, right? So you don't want to really do that. But all they do is install that hook that's triggered every time you check something into GitHub. So once that hook is installed, I went back and withdrew my authorization. So the hook still works, of course, because it's in place. But I'm not saying they do anything with it, but I'm just careful. So once the hook is in place for a repo, that will just stay there and the tests keep running. And as I said, it's really fascinating that you have the Travis in one window and you submit a commit to GitHub, and all of a sudden it dynamically updates. So very fascinating. They also have an API. So if, for example, for the Pogo case, you can just curl this JSON REST interface, and then you get back when your build succeeded or failed, and a little bit of history also.
Does that have a callback mechanism so you can put in the client side API?
That I haven't figured out. Randall's asking if it has a callback mechanism. Usually those REST interfaces are supposed to have one so that it can be run in a browser, but I'm not sure if they actually do. By the way, they're using pretty much the same interface as GitHub does. So it's also maybe based on the same Ruby or Rails implementation. We're almost at the end of the allotted time, 3 minutes to go. Is there any more questions?
What's Travis's model? Why are they doing this?
What's Travis's motto? That's a good question. I haven't asked. I suppose, so they're currently claiming that it's alpha, so you can't really rely on it. And they're getting some load numbers that way, I suppose. So it's also based on workers, because they need to queue up stuff if it gets too much. And maybe they just want to figure out how well it works and then later charge for it, I suppose. But the integration is what struck me. So every integration should be as easy as that. You could even think that GitHub would implement something like this. They maybe just hadn't thought of it. Question.
Yeah, do you guys build binary packages, or do you deploy from source to build on machines, or how do you do that?
So the question is, how do we deploy stuff? Do we create binary packages? And we do something similar than like creating Debian packages. So we have a package repo that we push the compiled sources in there, and depending on the language, if it's Perl, then it's all source, but if it's C code, then it's all compiled. So it's very similar to a mechanism like RPM or dpat or like apt-get for Debian. All right. Thanks for attending.